Okay, so this is Emily and I's research project on black holes. What exactly is a black hole? It is a region in space in which nothing can escape, resulting from a curving of space-time caused by a very large mass. So this might sound confusing now, but I'll explain more later. It is actually undetectable by the human eye, which has made its existence very hard to prove. But research has led to the conclusion that they exist in almost every galaxy of our known universe, including our own. And this is an image of a black hole that is centered in the Milky Way galaxy, only about 25,000 light years away from us. This is a supermassive black hole, and they're more rare, and they're mostly found in the center of galaxies. But they're actually smaller stellar mass black holes that exist in hundreds of millions in our galaxy. So the existence of black holes was hinted at as early as the 1780s, when John Michell assumed that a body might have the same density as the sun once its diameter is 500 times greater than the sun's, and its surface escape velocity is greater than the speed of light. He excited the scientific world by proposing the idea that non-radiating invisible bodies could be observed by their gravitational effect on other bodies. However, it was unclear how light would be affected by the traditional Newtonian gravitational field, so this idea was put aside. In 1915, Einstein predicted the existence of black holes once again with his theory of general relativity. In simple terms, this is the idea that space and time are two aspects of space-time. Space-time is curved when there is gravity, matter, energy, and momentum in large amounts. And this is a simplified equation explaining space-time, or general relativity, and this is an image showing the curvature of space-time for a visual. Einstein's associate, Carl Schwarzschild, found a solution that completely describes how space-time is warped outside a spherical object like a planet or star. He found that for very compact, high-density stars, it becomes much harder for anything, including light, to escape the gravitational field of the star. Although Einstein's general relativity proved their theoretical existence, throughout the 20th century, black holes remained a mere mathematical curiosity. But in 1971, the first physical black hole was spotted. And recently, in 2019, the Event Telescope Horizon released the first image of a black hole in the center of the galaxy called M87, which expanded the area of research for black holes now that scientists actually knew what they look like. And here on the right is the recent image that was taken in 2019 of the first black hole to give us an idea of what they actually look like. So some of the benefits of black holes are that the first images have proved to us the accuracy and extremity of Einstein's general theory of relativity, and which is crazy because Einstein himself admitted that he didn't even know if they existed. And they've proved to be an essential tool for testing the fundamental laws of the universe. We can use black holes' extreme gravitational field to find out more about like other planets and stars. So there are no actual downsides to black holes, but their discovery has encouraged a new fear among scientists and people. Director of the Event Telescope Horizon, Doleman, sums this up very well by saying, and the reason they're terrifying, the reason this is an important image, is because when you look into the middle of it, you realize that we've theorized about these monsters being out there, and now we know they are. And what's more, now we see them. This is the only place in the universe where the cosmos tie a knot you can't untie. Every other place in the universe you can, in theory, come back from, but not here. And also, a black hole would have to be very close to the solar system to affect Earth, which is not likely. And if a black hole were to replace the sun once it collapses, the Earth would not fall in because the black hole would keep the same gravity as the sun, and therefore Earth would remain in its same orbit.